Hello! Today I'm Farmer Huckleberry, and have I got a problem for you? I've got this farm where I grow huckleberries and blueberries, and I'm trying to figure out how to maximize my profit on that farm. So I've decided to go ahead and use some math. Now, X is going to be the number of huckleberry acres I grow, and Y is going to be the number of blueberry acres I grow. I've got to grow a little bit of each, and we've got some reasoning for that in a few minutes. Now, I told you I was trying to maximize my profit. We're going to call that the objective function. It's my goal, my objective, what I want to get maximized. Now, if I wanted to do a minimum, same idea. Your objective is a minimum in that case, and we can find it in the same way. But in this case, we want to maximize profit, right? Okay, so I got some constraints I got to work within. Now, one of the obvious ones is a non-negative limiter. It's impossible for me to grow a negative amount of blueberries or huckleberries. That just doesn't make sense, right? Why would I do that? I've got to grow 0 or more. So, X being the number of huckleberry acres I grow has to be greater than or equal to 0. That's a constraint I just have to work with. And Y being the number of blueberry acres that I grow has to also be greater than or equal to 0. So that's why I've drawn my coordinate plane only in the first quadrant. I've limited it there. I'm not worried about the second, third, or fourth quadrants. So I've drawn it for that reason. Now, I got a couple other constraints other than I got to just grow more than nothing. My farm is only 60 acres in total. So my total amount of huckleberry and blueberries that I grow can't exceed 60 acres. I can get to 60, but I can't exceed it. So that's where I get this constraint. X plus Y, the number of acres of X plus the number of acres of Y, has to be less than or equal 60 total acres. So if I go to graph that over here, I'm going to go ahead and graph that by intercepts. I'm going to realize that if Y is a 0, X is a 60. So I'm going to mark that point there. And if X is a 0, right, Y would be a 60. So I'll mark that point up there. So let's see. As best I can there. Now, we're going to remember that for this one, we're already graphing or shading to the right. Here, we're shading above. But this one, we would be shading below. If we did a test point, 0 plus 0 is 0, which is less than 60. So this is in the shaded region. So we're just right now, we're going to remember that we're shading this triangle because we've got a few more to do. I don't want to overburden the picture. So Y, the number of blueberry acres, has to be greater than or equal to 10. Now, that has to do with a whole other business I have making smoothies, where they're huckleberry smoothies and blueberry smoothies and, blah, blah, blah. So I need to have a certain amount of blueberries grown for that business already. So that's why Y has to be greater than or equal to 10. So we could think of that as Y equals mx plus b, or Y is greater than or equal to 0x plus 10. 10 would be your y-intercept, and your slope would be, 0. It'd be flat. So we're going to have a line like this. And since all of these are or equal to, you'll notice that's why I'm doing solid lines here. Okay? So that would go on through there. This guy would go on through there. That guy would go on through there. But now, which way are we going to shade? Y is greater than, and remember, if Y is by itself, we get to read it to determine which way it shades. It says Y is greater than, so I'm going to be shading, above. So now we're in this triangle. Now here, remember, that's a compound inequality, and we can break that apart into an and statement. So we can realize that X is greater than or equal to 20, and X is less than or equal to 40. Now remember, when graphing X equals, we can't define that as Y equals mx plus b, so we have to realize it's an undefined slope, a straight up and down line. So X is greater than or equal to 20 would put our straight up and down line here, like so, and greater than or equal to 40, let's see, 10, 20, oops, wrong place, Mr. Manning. It's the finger eraser, right? It's here, isn't it? Okay, and then less than or equal to 40, 10, 20, 30, 40, it's right about there. Okay, and again, hopefully we're noticing that we would have shaded to the right of this and to the left of that. X is greater than or equal to 20, so that's the only time we think of it as left and right. Remember, greater than to the right, less than to the left. Otherwise, it's above or below. And so ultimately, our total shaded region, or our solution region, is here. Now, the corner point principle tells us that the vertices of that solution region, those vertices are going to be the location where we're going to find the maximum as well as the minimum for our objective function. Now, in this case, we're mostly interested in the maximum because we want to maximize our profit for the farm. So the next thing we have to do is we have to identify where these vertices actually are. And sometimes it's as easy as just eyeballing it with some logic, because we realize with vertical lines intersecting like so, it's pretty easy to figure out. Like right here and here, this is 1, 2, 3, 40, 10. Let's go ahead and put that point in, 40, 10. Over here, that's that point. Over here, that intersection is at 20, 10. Up here, that's at 20. Now, if you're not quite positive, we can solve the system of equations fully, but in this case, we already know the x value is 20. So we could plug that into this equation, which was that one, and find it would have to be at 40. So 20, 40. And finally, this one right here, x is 40, and y is, again, same thing. We could plug it in there. 40 for x would mean y would have to be 20. So now we've got our vertices for our solution region. Now we're going to plug those into the objective function. And that way we'll find the profit and figure out which one is the highest profit and which one's the lowest profit. So what we're going to do, get out the calculator, and we go ahead and plug them in. Oops. And we find that at 40, 10, we get $30,780. Oops, bad pen. 30,780. That's pretty high. Cool. At 20, 10, 17,100. Wow, that is a big difference, isn't it? I'm glad I did some algebra here. This way I know that's a lot better than that, even if that's where I start, right? So let's see, 20, 40. 27,360. Okay, not as much. That's looking like a winner right now, but look at this. 40, 40, 10. This is going to be bigger, isn't it? So we're going to plug that in. 40, 20. And we end at, yep, $34,200. So there's our big winter. What we want to do is we want to go ahead and grow 40 acres of blueberries and 40 acres of huckleberries. Got to get that right. And 20 acres of blueberries. That way you get the maximum profit, folks. Right on. Have a good one out there and enjoy a smoothie. See ya.